All right, today we are diving into a thought experiment that is, well, literally out of this world. We're going to explore an absolutely wild scenario that comes from the brilliant and kind of bizarre mind of XKCD's What If series. So, here it is, the big question. What would actually happen if we could just snap our fingers and teleport every single drop of Earth's oceans straight to Mars? I'm not talking rockets or some centuries-long project. I mean, poof, it's just there.
And you might be asking, why would we do this? Well, the reasoning is pretty simple. You see, the Curiosity rover is up there working its wheels off, trying to find just a tiny little bit of evidence of water. So why not make its job a whole lot easier by giving it all the water? All at once.
Okay, let's really break this down. What happens in that very first moment when this ultimate water delivery arrives? We are talking about a volume of water so huge it's almost impossible to wrap your head around, just appearing on a planet that is completely, totally unprepared for it. Now, I bet your first thought is the same as mine. Mars is ridiculously cold, and its atmosphere is super, super thin. So logically, any liquid water we dump there should either freeze solid or just boil away into space almost instantly, right? That's got to be the first big problem. But this is where it starts to get really interesting. See, we're not just pouring a bucket of water here. We are dumping an entire planet's worth of oceans. The sheer volume and the unbelievable speed of this flood would just overwhelm the cold. And don't forget, Earth's oceans are salty, and salt water has a lower freezing point. That gives it a pretty crucial head start. Okay, so let's zoom in on ground zero. The idea is that the portal opens right above Gale Crater, which you might know is the current home of the Curiosity rover. And for poor Curiosity, this is where things get really bad really fast. Just try to picture it. The water starts gushing in, and Gale Crater, this is a basin that's 154 kilometers wide, just begins to fill up like you're running a bath. Our little rover, after all that hard work looking for a drop of water, would be buried under hundreds of meters of salt water in minutes. And this is where the physics gets super weird. The freezing Martian air would start to freeze the surface of this new ocean, right? Creating a lid of sea ice. But at the exact same time, the frozen ground of Mars would freeze the water from the bottom up. So you end up with this bizarre ice and dirt sandwich, with a layer of liquid water trapped right in the middle. This bizarre freezing process leads to something brand new. As that bottom layer of water freezes, huge chunks of rock and frozen soil would break away from the crater floor and start to float upwards through the water, just like icebergs do on Earth. Except these aren't made of ice, they're rockbergs, a totally new Martian phenomenon. Of course, all that water isn't going to just stay put in one crater. As the oceans keep pouring through that portal, we go from a local flood to a full-on planet-wide cataclysm, the Great Martian Flood. So how does this whole thing play out? Well, first, the water spills over the northern edge of Gale Crater. Gravity takes over, and it carves this massive path north, eventually pooling in the huge North Polar Basin. And from there, it's going to keep going until it crashes into the lowest point on the entire planet, the Hellas Impact Crater. I mean, its arrival at Hellas Basin would be an unbelievable sight. A massive waterfall, choked with ice, and those new rockbergs we talked about, just thundering down into the crater. And unfortunately for our other famous rover, Perseverance, which happens to be right in the path, well, this event would mean a very quick, very certain end. So to kind of sum up the situation for our robotic explorers on Mars, they are not having a good day. They're officially waterlogged, and yeah, I think it's safe to say their warranties are now definitely void. So once the portal from Earth finally closes and the water settles down, the chaos is over. Mars is completely transformed into this new, seemingly stable world. But what does that world even look like? The new Mars is an ice world. A gigantic, planet-spanning ocean now covers all of its lowlands, but it's sealed under this thick crust of sea ice. And floating silently below in the dark, salty water are those bizarre rockbergs. And it seems like this story has a pretty clear ending, doesn't it? Over the years, the relentless Martian cold would just keep doing its thing. That ice cap would get thicker and thicker and thicker until eventually the entire ocean freezes solid, from top to bottom. A dead, icy world. End of story. Or is it? Well, here's where the whole story takes a massive, unexpected turn. Because what if that deep freeze isn't how this story ends at all? What if everything we've just laid out, The flood, the freezing, the Rockebergs is totally wrong. What if we've missed one single crucial variable in this entire planetary equation? And here it is. This is the game changer. Water vapor is an incredibly powerful greenhouse gas, and with an entire planet's worth of new oceans sitting on the surface, a ton of it would start to evaporate into that thin Martian atmosphere. And this one thing, this one variable, creates two totally different futures for Mars. In one, the big freeze, Mars just becomes a giant ice ball. But in the other, the big thaw, all that evaporating water creates a thick, soupy atmosphere that traps heat. And this new atmosphere could actually warm the entire planet up, maybe enough to keep the oceans liquid. So think about that. Instead of a frozen wasteland, teleporting our oceans could actually accidentally terraform Mars. It could create a warm, wet, stable world with liquid oceans and a thick atmosphere, kind of like Earth. We set out just to make things a little easier for a rover, and we might have ended up creating a second Earth in the process. So which one would it be? The big freeze or the big thaw? The science could point in two completely different directions. And as our source material cheekily puts it, when you really get down to it, there's only one way to find out. Thanks for joining me.